Well, good afternoon. My name is Bardia Bina, and I'd like to thank you so much for giving me this opportunity to tell you about something that I'm personally very passionate about, and that is taking the success of augmented reality from the aerospace domain to the operating room. For many years, augmented reality has been used very successfully in the aerospace domain to not only enhance operative performance, but also to enable pilots to perform missions and maneuvers that's otherwise not possible to do. We can make the invisible visible by combining different imaging modalities and increase operator situational awareness by presenting them with information that's available from other sensors that are part of the system. By visualizing markings and visualizing pre-planned trajectories, we allow pilots to perform very intricate maneuvers following pre-planned paths in 3D space with incredible accuracy. In neurosurgery, surgeons have access to a wealth of imaging information from different modalities, and they heavily rely on preoperative planning and preoperative imaging in order to carry a particular procedure. But unfortunately, that imaging is not currently presented to them in an integrated and intuitive manner. So what I propose is developing an augmented reality system that enables the surgeon to take preoperative information and preoperative imaging and superimpose that directly onto the optical path of a surgical microscope or surgical laparoscope, thereby not only increasing their performance and accuracy, but also reducing possibility for error. To reduce time to market for such a complicated proposal, I propose releasing the system in a set of 3 phases at different stages of the technology development. So after the first phase, we'll release the system for free as a tablet-based augmented reality tool for studying and exploring the brain and the nervous system. And this serves multiple benefits. One being it allows us to quickly test our technology platform early on in the technology development phase. 2, to start building a brand. 3, to use that as leverage to attract other investors. And lastly, this is actually in line with one of Ontario Brain Institute's initiatives to actually educate the general public about the human brain and the various diseases associated with that. This system, the user base will be undergraduate students and the general public for the system. From there, we'll go on to the second phase, where we'll continue with technology development, and at the end of that, we'll release that as an educational tool. So the customer base at that point will include medical students, neurosurgery residents, and educational institutions. The costing model at that point is going to be a freemium model for students and a low-cost licensing fee for educational institutions. And at this point, this release will not only start to generate some revenue for us, but it will also have the added benefit of continuing to build our brand in the medical community, as well as actually doing testing with real users in the field to hammer out any functionality or usability issues early on. In the last phase, we'll continue to develop and fine-tune the system for it to actually be used in procedures in the operating room. And at that point, we'll actually pursue partnership and licensing with other device manufacturers in order to leverage their distribution channels. I won't talk about the market right now. So just to close, I want to say that in their latest issue, Inc. magazine rated wearable computing as the #1 industry in which to start a business. And as wearable computing becomes ubiquitous in the next decade, augmented reality will be the technology of choice for displaying visual information. And with that, it's going to change the way we work and we learn. So what that means is that by the time our technology is ready to hit the market, we will not have to convince the surgeons of the benefits of augmented reality. They're going to be the ones who are going to be asking for this.